Form 3 Chemistry Lesson 1. This lesson is on the speed of reaction. The speed of chemical reaction is also known as the rate of chemical reaction. What is a chemical reaction? A chemical reaction is in which the reactants are changed into products. In this reaction, methane CH4 and oxygen O2 are the reactants. The reactants are one molecule of methane CH4 and two molecules of oxygen O2. These two react to form the products. The products are carbon dioxide CO2 and H2O in the form of steam. You have one molecule of carbon dioxide and two molecules of steam H2O as the products. A chemical reaction is in which the reactants are changed into the products. What is a rate? A rate is a measure of how fast or slow something is. What is a reaction rate? Reaction rate is the measure of how quickly the reactants in the chemical reaction are changed into the products. Some reactions are slow, but some are fast. Some reactions have slow rate, but some reactions have a fast rate. Examples of slow reactions are, for example, rotting of vegetables and fruits, rusting of iron, which takes several months. It's a very slow process. Formation of coal. These are all slow reactions. Examples of fast reactions: fireworks, burning of wood, combustion of natural gas. The reaction between sodium and water is also very fast. We can measure the rate of chemical reaction. There are different methods by which we can measure the speed of a chemical reaction. We can measure the volume of gas given off. Suppose there is a reaction in which a gas is produced. So we can measure the volume of that gas using a gas syringe. We can measure the volume of that gas to find out the speed of that reaction. Or we can measure change in mass. We can measure the decrease in mass of reactant using an electronic balance. Or we can measure the change in temperatures using a thermometer. Some reactions are exothermic, so the temperature on the thermometer will rise. But some reactions are endothermic, so the temperature will drop. But we can measure the change in temperature, either the increase in temperature or a decrease in temperature, to measure the rate of that reaction. We can measure the color change. Suppose there is a reaction in which reactants are colorless, but the products are colored. So we can measure the formation of that colored product to find out the speed of that chemical reaction. Or we can measure the formation of precipitate. A precipitate is an insoluble solid. Suppose the reactants are soluble in water, but the products are insoluble in water. They form precipitate. So the products are insoluble in water. That means the products, they form precipitate. So we can measure the formation of the insoluble solids to find out the speed of that chemical reaction. A precipitate is an insoluble solid. Or we can measure the pH changes. The pH stands for of hydrogen. Suppose there is a reaction in which acids or alkalis are present. So we can measure the pH. Acids have pHs from 0 to 6. Alkalis have pHs from 8 till 14. So we can measure the pH using a pH meter if a reaction has acid or alkali present. So these are the different methods by which we can measure the speed of a chemical reaction. We can measure the volume, the mass, temperature, color, precipitate, or the pH. Depending on what type of reaction is going on, we can choose any one of these methods to measure. This is the experimental setup to measure the volume of gas produced. The reaction is between calcium carbonate and dilute hydrochloric acid. And in the product, you can see a gas is being produced, which is carbon dioxide. So the reactants, calcium carbonate and dilute hydrochloric acid, are in the conical flask. When the gas is produced, it passes through the delivery tube and is collected in the gas syringe. So we can measure the volume of gas collected in the gas syringe to find out the rate of this reaction. We can then plot a graph between the volume of carbon dioxide collected and the time. So at the start of the reaction, there is no carbon dioxide in the gas syringe, so the volume is 0. But as soon as the reaction starts, the volume of carbon dioxide increases in the gas syringe. And as soon as you see the straight horizontal line, this means there is no more increase of gas in the gas syringe. That means the reaction is finished. Either one or both of the reactants are finished. As soon as you see the straight line, that means the reaction is finished. This experimental setup is to find out the decrease in mass during a chemical reaction. The reaction is calcium carbonate, which is also known as marble chip, and these are solid pieces. Those solid pieces are reacting with hydrochloric acid and a gas is produced. That gas escapes from the cotton wool. So we can measure the decrease in mass on the electronic balance. Calcium carbonate, first they were solid pieces. So there was more mass at the start of the reaction. But as carbon dioxide gas escapes, there will be a decrease in mass on the electronic balance. This is the equation to find out the rate of chemical reaction. So we can find out the rate of chemical reaction by dividing change in volume or change in mass by the time taken. Okay, change in volume or change in mass divided by the time taken will give you the rate of that chemical reaction. Factors affecting rate of reaction. There are different factors which affect the rate of reaction. The rate of reaction can be increased or decreased depending on these factors. These factors are the temperature of the substance used, the concentration of the substance used, the pressure on the reaction, the particle size of the substance used, and the catalyst. There are 5 factors which affect the rate of chemical reaction: the temperature, the concentration, the pressure, particle size, and the catalyst. Temperature, concentration, pressure, particle size, and the catalyst. Before we understand how these factors affect the rate of the reaction, we need to cover the theory behind the reaction, which is known as the collision theory. The collision theory states that for particles to react, they have to collide with enough energy, sufficient energy. But if they collide with less energy, then no reaction will take place. They will simply bounce apart. For any chemical reaction to take place, the particles have to collide with sufficient energy. Suppose there is a reaction of A and Bx and the products are B and Ex. First, these two reactants, they have to collide for the products to be formed. First type of collision is when A is colliding with Bx, but they do not have sufficient energy. They are colliding, but energy is not sufficient. So no reaction takes place. In the second type of collision, A and Bx are colliding, but this time the reaction is taking place because the collision is very effective. It's full of energy. So for the reaction to take place, the collision has to have an effective collision. The rate depends on two main things: the amount of energy the particles have and the frequency of collisions. The amount of energy the particles have, the more energy they have, the more energy they can transfer on collision. So there will be faster rate of reaction. The second factor, the frequency of collision. The more often they collide, the more successful collisions will be. Okay, so the rate depends on two main things: the amount of energy the particles have and the frequency of collisions. So now, whenever you think of how these factors affect the rate of the reaction, you should always think in terms of the amount of energy and the frequency of collision. There should be more amount of energy, there should be more frequency of collision, then only the reaction will take place. The first factor is temperature. If the temperature of the reaction is increased, the rate of the reaction increases. Why does it increase? Because when you are increasing the temperature, the heat energy increases, the kinetic energy increases, so there will be more effective collisions and the rate of reaction increases. The particles have more energy. When you increase the temperature, heat energy increases. Particles gain heat, so they start to vibrate faster and faster. So that means the kinetic energy is increasing. When kinetic energy is increasing, there are more successful collisions. And when there are more successful collisions, the rate of the reaction increases. So in general, the speed of the reaction increases if the temperature of the reactant is increased. If you decrease the temperature, then the heat energy decreases, the kinetic energy decreases, there will be less effective collisions and the rate of reaction decreases. The second factor is concentration. Suppose in a container there are less particles. So there are less particles, that means lower concentration of molecules. When there are more particles, that means there are more crowded particles, which means there will be more effective collisions and the rate of reaction increases. In general, reactions are faster if the concentration of reactants is increased. Increasing concentration, more crowded particles, more effective collisions, and the rate of reaction increases. If you decrease the concentration, less crowded particles, less effective collisions, and the rate of reaction decreases. In general, reactions are faster if the concentration of reactant is increased. Pressure only affects the reactions in which gases are involved. Okay, so in a gaseous reaction, the speed of reaction increases if the pressure is increased. Suppose there is a vessel in which you have gas particles. If you increase the pressure, now the same amount of gas particles are present in less volume. So that means they are more crowded. So more crowded means more effective collisions and the rate of reaction increases. In a gaseous mixture, the speed of reaction increases if the pressure is increased. The next factor is the particle size. Smaller particles like powders have much greater surface area than larger lumps. With a greater surface area, the other reactant can attack it more easily and thereby increase the speed of reaction. The greater the surface area, the faster the rate of chemical reaction. Smaller particles have larger surface area. Suppose in this beaker, one reactant is in the form of lump. That means it has low surface area. So this reaction would be slow. The rate of this reaction would be slower. But if you break this big large lump down into smaller pieces, now these smaller pieces have larger surface area. So more effective collisions and the rate of reaction increases. Smaller pieces have large surface area and therefore more collisions. The last factor is a catalyst. A catalyst is a substance which increases the rate of chemical reaction without itself being chemically changed at the end of the reaction. A catalyst speeds up a chemical reaction. Why does it speeds up a chemical reaction? Because it lowers the activation energy. A catalyst lowers the activation energy and speeds up a chemical reaction. What is an activation energy? It's the minimum energy needed to start a reaction. You have to overcome the activation energy, then the reaction will start. Here we have two energy profile diagrams. One is for endothermic reaction and the other one is for exothermic reaction. And you can see the activation energy in the endothermic and the exothermic. The catalyst lowers the activation energy. What is an activation energy? The minimum amount of energy which the reacting species must possess in order to undergo a reaction. Catalyst works by lowering the activation energy. This is the energy profile diagram for an exothermic reaction, and this is the activation energy. Okay, this is the reaction without a catalyst, but when a catalyst is added, it lowers the activation energy, which means the reaction now takes place quickly, faster. The catalyst works by lowering the activation energy. Here are a few practice questions for you to do. The answers of these will be discussed in the next lesson. So MCQ number 1. How does a catalyst increase the speed of the reaction? A is by increasing the collision frequency of particles. B by increasing the speed of the particles. C by increasing the temperature of the reaction. And D is by lowering the activation energy. How does a catalyst increase the speed of a reaction? Question 2. Copper 2 carbonate powder was heated. The loss in mass was plotted against time as shown in the graph. Okay, this is a graph drawn between the loss in mass against time. During which time interval is the reaction the fastest? MCQ number 3. Limestone reacts with hydrochloric acid. Changing which reaction condition does not affect the rate of reaction? Concentration of the acid, limestone particle size, pressure, or temperature? Question 4. Aqueous hydrogen peroxide H2O2 is used to sterilize contact lenses. H2O2 slowly decomposes at room temperature to make water and oxygen. Decomposes means it breaks down. Okay, so it slowly breaks down at room temperature to make water and oxygen. Water and oxygen are the products. This decomposition can be made faster. This reaction can be made faster by using more concentrated solution, by heating, and by adding an enzyme. An enzyme is a catalyst, biological catalyst. First question is construct the equation for the decomposition of hydrogen peroxide. This equation must be balanced. Explain why concentrated H2O2 decomposes faster than dilute H2O2. Okay, so it's concentration. Concentrated decomposes faster than dilute. Why? Explain why hot hydrogen peroxide decomposes faster than cold hydrogen peroxide. Okay, this is to do with temperature, hot and cold. Next question, explain using ideas about activation energy why an enzyme such as peroxidase makes the decomposition of H2O2 faster. Okay, enzyme is a biological catalyst. Next question, describe with the aid of a label diagram how you could carry out an experiment to collect the volume of gases.